Welcome to the Pardee Symposium at the Geological Society of America. It's a real honor to be part of this symposium and talk about topics we often don't think about in relation to groundwater, about natural disasters, social ecological systems, art, and community-based research and equity. And I wanted to share to start with a small haiku that brings many of these ideas together. Groundwater connects to people and place. Let's all make that visible. In the background behind this haiku is an AI generated image of this title. So you can start to imagine all the people and all the different aspects that are at play here. And I also wanted to acknowledge my co-authors. There's a variety, both from my institution and from Japan and Sweden. And I just wanted to acknowledge their key role in this as we move forward. I also really want to acknowledge the importance of my social location and lands and places. So my background is a settler I grew up on Iroquois territory near the Six Nations. In what's now called Ontario. I come from a multi-generational settler family. This is a photo of my grandfather. My dad is the third boy from the left there on the settler farm. And I live now on Songhees, Esquimalt, and Wasanich territories on Western Canada. And I work and do a research project I'll describe is in the Coxsahla watershed in Cowichan territory in the Hochsila-Stalo River. And here we are on Tongva and Akaman homelands in what's called Anaheim. I think our approaches to groundwater sustainability are evolving. I've been involved in this domain for about 15 years. And I think when I first got into it, we were really focused and have been through time, and you'll see a number of these in other speakers here today, around really large scale work, so global scale, a very Earth systems approach of combining our work in hydrogeology with other aspects of the Earth system, and a real what I call physical sustainability approach. This is, I think, one approach that I got into when the forest was kind of small and the trees were just kind of growing. And I think over time, our approach to groundwater sustainability is evolving. And I'm going to talk about that in a few different ways here today. So first, in this more mature and I think beautiful forest is what I'm going to talk about moving across scales. So multi-scale approaches, including community-based research, a much more deeply interdisciplinary approach, including social ecological systems, and a real reliance and importance on focusing on equity and justice. So overall, the key message of my talk today is that we're bringing these new approaches to groundwater sustainability. And these approaches reach more people, engage issues more deeply, and describe systems more holistically. And I put new in quote marks there because they're really not new approaches, but we're bringing them to groundwater sustainability. So groundwater operates at a wide variety of different scales. This is a rather complex diagram where we have two x-axes. The lower x-axis is the number of people affected, because I think it's always important to remember people and social issues. On the upper x-axis is the scale, so you can see from 1 centimeter to 100,000 kilometers. And then on the y-axis is the number of years. So this is a time-space diagram. And much of the talks and effort in groundwater sustainability is focused around the center of this scale diagram and around groundwater depletion, saltwater intrusion, and land subsidence. Some other work relates to larger scales and climate systems and climate change, and then other work goes to smaller scales in groundwater-dependent ecosystems and groundwater surface water interactions, and even into porosity and the role of small-scale issues. But what I want to focus on as well is bringing our attention to social systems. And so again, these operate at a wide variety of different scales, including civil society, economic, decision-making, customs and rule setting, and groundwater modeling processes. So all of these are important and span a wide variety of scales. And I think, and this is work really I'm elevating here by former PhD student Xander Huggins, who really came up and has put forward this idea of groundwater connected systems. And what he argues is that all of these different elements somehow relate to groundwater, either directly or indirectly. And what I'm going to do today is focus on 3 areas that are emerging in my research group and related collaborators at a variety of different time-space scales. So from arts-based and community-based research, natural disasters, and social ecological mapping. And I'm going to try to tell the story of these three different themes through a series of three questions that are all rather people-centric. So the first one, again, I'm bringing people throughout this whole talk, is could groundwater reduce the impacts of natural disasters? And the second is, how could community-based research and art increase engagement with groundwater? And the third is, can we map how groundwater interacts with social, economic, or biophysical systems across the globe? I'm going to walk through each of those three different themes and bring them together at the end. So the first theme is, could groundwater use reduce the impacts of natural disasters? And here I was inspired by a recent research visit over 3 months to the Research Institute for Humanity and Nature in Kyoto, Japan. And just a couple of weeks before I went on this research visit, there was a large 7.6 magnitude earthquake in the Noto region, which caused extensive damage. This is a photo from one of the towns in that region. And a number of people lost their drinking water. And so I'm going to tell a story here to motivate this part of the talk. And so the story, I want you to imagine this person here saying, I lost drinking water at my house during the earthquake. And another person saying, do you want to use groundwater from my private well? I have it registered as an emergency well. And so these emergency wells are an amazing system that Japan has developed over the last couple decades. And now the majority of municipalities across Japan, from the north to the south, have plans to use groundwater in emergencies. And these plans use private wells and switch temporarily these private wells to public good. And they're used in neighborhoods in a very organic, yet pre-planned way. This was an important motivation for me to think differently about groundwater. I've often thought about groundwater in very long time scales, and it started me thinking about groundwater on shorter time scales. And what I mean by that is that normally when we think about groundwater resources or groundwater supplies in normal times, so non-emergency times, we've often characterized that as, and this is some excellent work led by Karen Velhoth on the panel here, as invisible, slow, and distributed. And I think that's a great way of describing groundwater supply in normal times. And we often think on very long time scales of years to decades, and we use water for irrigation or drinking water and worry about depletion and contamination. But I think another way that's quite important to think about groundwater during and after a natural hazard is actually using the same acronym, ISD, but different words. And so these words are inexpensive, speedy, and distributed. So the groundwater is still everywhere and distributed, but we can get at it relatively cheaply because the wells are already in place and relatively quickly. And so I've drawn here in kawaii characters with a shout out to my time in Japan, a turtle and a rabbit or hare, and they're both drinking from the same groundwater well. And so we're not talking about new resources or new technologies. We're talking about using the existing water resources in a slightly different way, in different timescales of hours to months, and using it for drinking water and fire suppression. And some of the challenges are access, contamination, as you'll see, policy. So we started thinking about this for earthquakes, but we quickly realized this could be useful for a wide variety of natural hazards. So here is a conceptual graph that we developed together during my time in Japan. And on the x-axis is the potential warning before a natural hazard. And I'll use drought in the top left corner to highlight this. So droughts have a very long warning time of days or even months, sometimes even years. Whereas on the y-axis is the potential water impact. We can have a significant water impact from drought. If we place all the other major types of natural hazards on this image, we see that there's a wide variety of different potential warnings as well as potential impacts on both the infrastructure of the water as well as water supplies. So again, the earthquakes up in the top right are very short warning, but very high impact, especially on water supplies and water infrastructure. The size of the circle in this image is related to the global frequency of these natural hazards. So you'll see a wide variety of different potential impacts and times. And what we also realized is that we could possibly employ a wide variety of different interdisciplinary approaches to using groundwater for these different natural hazards. Again, going back to earthquakes, we could move and reduce the susceptibility of people and water systems to these natural hazards by along moving horizontally in this diagram through earthquake science and communication that could decrease the potential warning before natural hazards, and a wide variety of other more equity and social justice related fields and tools such as disaster sociology and disaster environmental justice could potentially reduce the potential water impact of earthquakes. This is also true for other natural hazards as well, such as floods or wildfires. And I won't go through all the different methods and tools, but we can imagine that there are a wide variety of social science and physical science methods that could reduce susceptibilities if we enhance groundwater use during earthquakes. So the second theme that I want to talk about today is art and community-based research. And that research is really motivated by a specific watershed and people and community that I work with on Vancouver Island. And so the river in the background is the Hochsila River. And the person on the left is a PhD student, Christina Disney, who's been running a really successful community monitoring program for the last 3 years. And these are various community members who are asking questions of our project. How could this project further Indigenous rights and stewardship? How could stream monitoring help support salmon populations? And how could the project data be derived across the whole watershed? In the bottom is a QR code that leads to this project website if you're interested. So these questions simulate and support our research. And really, this is a community connected and strongly partnered project. We have partnership agreements with the First Nation Cowichan tribes, the provincial government, as well as 2 watershed NGO groups. And this is community science to support a first of its kind co-governance agreement where the First Nation and settler provincial government are working together to develop a watershed plan for this troubled river. And the research project and this new watershed plan is really in this era of the United Nations Declaration of Rights to Indigenous People, which sets out the rights, the inherent rights of all Indigenous peoples, and has been codified and passed in British Columbia and in Canada. And for the research project, we are following best practices in Indigenous data ownership. In Canada, this is called OCAP, Ownership, Control, Authority, and Possession. And this aligns with international standards for Indigenous data ownership as well. So what we've been doing practically for community monitoring is we have an app which we use called the Hochsila Stream Tracker. And it, with that and a temperature conductivity pen, community monitors go out in low flow season, so September and August, and monitor weekly or bi-weekly all the small water, headwater streams and tributary streams in the watershed for temperature, conductivity, stream width, flow, and presence. And what we can do with that data over the last few years is really map where across the whole watershed where streams are gaining and losing or disconnected, or where they're sourced from surface water. And this project has really increased engagement with the watershed. And here you see that this is just the start of this, but we have dozens of community monitors that are deeply engaged in the watershed. So we're responding to place-based communities and priorities with our environmental science and geoscience in community-based research. So we're melding these two together. And what I've been interested in more recently, and the team has been interested in more recently, is can we deepen this engagement through art? So the same place-based communities and priorities exist, and we're now relating to arts practices and arts-based methods and community-based art. And this project is a new project within the same area called Project 84,000, which was responding to a terrible loss of 84,000 salmon last summer. and honoring those salmon and the ecological grief related to that salmon, those salmon deaths. So over the last 5 or 6 months, hundreds of community members of all ages have engaged emotionally and artistically with the watershed and with ecological grief. And what they do is make images of trace images with crayon of salmon on this brown paper. And we've already passed the goal of reaching and making 84,000 salmon. And even just yesterday, we unveiled that at a community event. And this community-based arts and science has inspired me to think even more broadly about how art could be useful. And I've started researching different ideas and ways this can be done and different examples from around the world. So here's just a few examples of that from different places. There's a play about groundwater from India, some visual art inspired by the work of Grant Ferguson and Jennifer McIntosh from North America, Central North America, and a sculpture based on the depletion and groundwater irrigation pivot circles from the High Plains Aquifer. And finally, on the lower left, urban or graffiti art from England, which made an image of aquifers in an underpass. So all of these images together are very inspiring to me to think about how groundwater science can interface with communities and with art. The last theme I want to talk about is social ecological systems mapping and how we can map these across large scales. So existing aquifer mapping, some of which are being updated by Scott and others that he's working with. But the existing global mapping, often called YMAP, is of large aquifers around the world. And this is based only on the geology and geophysics of an area, and does not consider the ecological or systems or social and agricultural differences in these different places. So what we're doing here is showing you 3 different places from 3 different continents, all which are mapped by this as the same type of polygon in the YMAP data, but have totally different GDEs or groundwater dependent ecosystems, different agricultural uses, and different groundwater management. So you can imagine the actual groundwater sustainability issues in each of these places is really quite different. And so for this part of the talk, I want you to imagine, again, this is an imaginary table of stakeholders or people or knowledge holders from around the world. I generated this image, again, with AI. These people are asking questions. How does the size of farms affect groundwater sustainability in different regions? Or other questions like, where is irrigation most impacting groundwater-dependent ecosystems? Or where are groundwater-dependent ecosystems sensitive to climate change? And we can start to answer some of those questions by building different types of conceptual models that incorporate both the biophysical functions as well as the socioeconomic functions of groundwater. And so what you see here is a conceptual model, again, developed by Xander Huggins, of the 8 different types of functions that are all relate to groundwater in the Earth system, ecosystems, food systems, and water management systems. And we can use this type of conceptualization with a new approach to mapping what are called archetype mapping, sequential self-organizing maps. This is a quite complicated methodology, but it ends in reproducible, spatially mapped, and cohesive, what we now call groundwaterscapes. So this is an image of how and mapping of how groundwater interacts with the world around it. And Xander's analysis has shown that there's 18 different groundwaterscapes around the world, and that these are distinct, cohesive, and often are in different parts of the world. So there's just 2 examples to kind of give you a little bit of an image of what we mean by groundwaterscape. The one is from nearby here, like in the California Central Valley. This is groundwaterscape 8, which is large-scale agriculture dependent on groundwater. and another from the another side of the world, from Andhra Pradesh in India, where we have Groundwaterscape 9 as an example, which is smallholder farming, highly dependent on groundwater. So in both of these cases, we have important agricultural economies dependent on groundwater, but different farm sizes, which relate to are very important differences in how we manage the groundwater resources and develop policies. So this mapping of groundwaterscapes gives us a better chance to develop groundwater sustainability that is contextual and place-based. Unfortunately, what we also see when we compare groundwaterscapes with the previous mapping of large aquifers in YMAP is we see that most of the large aquifers of the world shown here as different polygons have multiple groundwaterscapes in them, meaning that treating the YMAP aquifer as one simple cohesive system is likely too overly simplistic. So my last question for this section is what could this map do for you? If you could place this in the middle of this hypothetical table of people from around the world discussing groundwater issues, how could we think differently about groundwater sustainability with this knowledge and mapping of groundwaterscapes? So to wrap up now, I want to come back to this time-space continuum that we started with and again plot the three different themes and approaches that we talked about. And starting with the first one, natural disasters, we saw how groundwater use could reduce the impacts of various natural disasters, and this would enable groundwater sustainability to reach more people. The next, we saw that community-based research and art increase engagement with groundwater, and this helps people engage emotionally and in other ways with groundwater issues more deeply. And lastly, we saw that there is ways of mapping how groundwater connects with socio-economic and biophysical systems across the globe. And this often happens in complex ways. I think this is a better way of describing groundwater connected systems more holistically. So to end, I'm going to just say again, I encourage you to come into this beautiful, complex, rich forest together with these new and quote unquote approaches to groundwater sustainability that reach more people, engage issues more deeply, and describe systems more holistically. Thank you for your time. And I'm just going to quickly mention a few things while I have people's attention of similar issues and initiatives that I've been part of. The first is a call to action from over 1,000 groundwater sustainability interested people from over 100 different countries. You can still sign this call to action if you're interested, as well as a video series that I co-led with Viviana Ray called Water Underground Talks, where we recorded 25 different videos by BIPOC and female groundwater scientists from around the world that can be used in teaching. And finally, if you still need a little bit of convincing that large-scale issues are important to groundwater, you can check out a previous talk from GSA, 5 Reasons Why a Global Perspective on Groundwater is Useful. So thank you very much, and thanks for the time, and I look forward to the rest of this session.